Hey, Topping Life Math and History, and we are going to take a look at equidistance theorems. So we're going to learn about two new theorems because they'll unlock even more power and unlock even more knowledge with geometry. It will also decrease the confusion with geometry proofs. So let's start at the first one. When you think of equidistant theorems, what do you think of? Well, you already think of the word equal, because it says the word equidistance. So let's start learning about it. What's this? It's a theorem. Equidistance theorem. When 2 points are the same distance to form a third point. So what it looks like to me is y and z are the same distance by measurement away from point x. So if you say this in mathematical language, we could say y and z are equidistant to x. Let's think of an endgame, because imagine x is the point and you're trying to throw two strings. One to point y and one to point z. Those two strings are the same measurement. Do an endgame.
5, 4, 3, 2, 1.
Perfect endgame. So let's think of a robot launching an endgame for Vex Robotics. So that is what equidistance means. When the equal measurements, the distances are equal to each other. That's why they have the word equal distance. So they're equidistant to each other. That is one theorem. Not only that, it will also unlock another theorem that we're going to look at. Wait, what is this? What? Perpendicular bisector theorem. If 2 points are each equidistant from the endpoints of a segment, then 2 points determine the perpendicular bisector of that segment. We don't really understand what that means yet, because that kind of sounds complicated. So let's get to our proof. But the problem with proving things is, before you prove that you know how to prove that proof, what is a perpendicular bisector? Well, this diagram is a great example of that happening. So there are two lines, and a perpendicular bisector theorems happens when two lines, a line bisects another line at 90 degrees and can make right angles. Not only that, the point from here, point C, to let's say the middle is point F, point C and point F, the segment CF has to be congruent to the segment DF. So not only it strikes through another line that makes perpendicular lines, but it also makes two congruent segments. So let's try and reread the problem and try to understand what happens. If 2 points are each equidistant from the endpoints of a segment, then 2 points determine the perpendicular bisector of that segment. Let's understand that by proving the theorem. Okay, so here's the proof. Given AB is congruent to AD. So we're going to say AB is congruent to AD. We can also say that from our givens, BC is congruent to CD. So those two segments are congruent. However, we have to prove that AC is an angle bisector of BD. So we're going to try and understand, how does AC strike through BD? And how does it make right angles right there? Right there! If you ask online how are we going to prove this, Well, you got all the parts already, because let's go back at the problem and reread it again, but also identify the picture, because we already proved it, but how? If 2 points are each equidistant from the endpoints of a segment, so these two are the endpoints of one segment, and these two are the equidistance from that segment, so BD are equidistant to A. Also, BD are also equidistant to C. Then, 2 points determine the perpendicular bisector of that segment. So we know that these two are congruent, and it also means that AC has to strike through and become a perpendicular bisector of BD. Now there are right angles inside of those. So just with that little information, proving that 2 points are equidistant of 2 endpoints, then we can automatically prove that the middle right here, AC, is a strike-through of a perpendicular bisector. For short, we can say PBT for initials, perpendicular bisector. Doesn't this kind of look like, if you ever practice a religion, doesn't this kind of look like a cross, kind of? It kind of does. That was a video of St. Carlos having fun in his childhood. He died at 15 years old and is almost going to become a saint. Who knows? Maybe he will. Let's try a challenge where we have to find those parts in order to prove that the cross or the perpendicular bisector is right there. Ooh, another proof. This time we actually have to find the parts. But this time they may be hiding. So given circle Q, we have a circle. We could say that AB is congruent to AC. So AB and CA are now congruent. We could also say, wait, there are no more givens. We have to prove that AD is perpendicular to BC. What? So this time, we are not trying to prove an angle. No, we are not trying to prove a perpendicular bisector. We have to prove that AD is perpendicular to BC. However, you are required to learn and prove this before you are required to prove that. So let's get started. We already have our givens. So when you think of the word circle, there is a proof that you probably might want to start with. We can understand that DQ, because Q is the middle of the circle, is going to be congruent with QA. Not only that, we're going to say DQ is going to be congruent with QA. Not only that, we could also, we have to do something else first. All radii of a circle is congruent. But the reason why we were talking about another set of these, or the reason why we stopped when we made this part of the proof, is there's still more hidden information. Take a look at B and see the distance between Q. From the proof, it literally said, all the radii have to be congruent. Therefore, we can say that an imaginary line from B can be touching Q. An imaginary line from C can be touching Q. And we can also draw those lines as well. So now we could say that BQ is going to be congruent to CQ. But before we say that, we have to say that BQ is a segment. We also have to say that CQ is a segment. So this has to be number 2, and these have to be number 1 first. The reason why we can say that both of them are 2 points can bring you a line segment.
Draw a straight line. Cool! You made a slide. Flick left to swing the rope.
So we gotta understand that we drew those lines first. So we can now say BQ is congruent with CQ because of this right here. All radii of a circle is congruent. So we have found all the parts that we need. We understand that BA is congruent to CA, but now we also proved with the radii of a circle that BQ is congruent with CQ. It doesn't matter if it has to look like this, like a cross. It only matters if there are 2 points that are equidistant from another endpoint, which are 2 points. So, right here, we have B and C are equidistant to A, and B and C are equidistant to Q, which also means, done! We have got our answer. We have now proven that AD of the segment is perpendicular bisector. And the reason why we can say P, B, T. The problem said we have to prove that AD is perpendicular to BC. And it does say that AD is perpendicular bisector. The only thing we need is that AD is perpendicular. The bisector part was another part that we just found as extra information. So now we have proven, I'm going to highlight, that AD and BC is going to be perpendicular. And that concludes the video. I hope this video has helped you understand equidistant theorems. Thank you for watching Talpinian's Math Industry. Like and subscribe.